Welcome, everyone. We will begin. Thank you again for taking time off to join us on this next webinar. We're trying to do this once every month. In this webinar today, we will address the communication technologies that are needed for smart utilities. Before I continue, I just want to check with somebody internal in Tejas. Am I perfectly audible?
Yes, Kumar, you're audible.
Okay, thank you. So what we'll cover today is we'll look at what is the emerging needs of the utility sector for communication. We'll look at it in three different sectors: power, railroads, and oil and gas. And then finally, we'll spend some time on how Tejas is addressing this with new products and solutions. I will cover the first three segments, and then I have my colleague, Dr. Sharat Kumar, who will cover the other two. If you have questions, please type it in the Q&A window or not in the chat window. You may type questions anytime, but we will answer them at the end of the webinar. So if you look at the utility sector, even for the utilities, telecom is the lifeline of the utility sector. Because there's a lot of internal communications that depends heavily on telecom. And this has always been the case. You might also be interested to note that essentially power utilities and telecom started at roughly the same time. Edison and Bell. The railroad started a little bit earlier. Now, if you look at the bandwidth requirements of utilities, you see the blue curve on the right used to be two peaks. One which was around 1 megabit or 1 to 2 megabits, which was the low-speed communications, and another one around 100 megabits, which was the high-speed communications, Ethernet or something. If you look at what's happening in the next 3 to 5 years, the peak at 1 to 2 megabits is now replaced by a peak around 10 to 50 megabits. And then the 100 meg is becoming 1 gig. So communications is 10x more in terms of bandwidth in the next generation. And this is happening because the utilities themselves are internally modernizing. There's also a lot of real-time monitoring of assets, performance, video-based monitoring, which drives the very high capacity requirements. And also telecoms become cheap and affordable to do at very high capacities. So what we can expect is that there's a 10x increase in the traffic in the next 3 to 5 years. And if you look at the chart at the bottom right, the media is going to fiber. You might think this is not decisive, but utility has to be very stable. So movements happen somewhat gradually in this utility sector. But you can more or less see that there are 20 odd utilities of the ones surveyed here which had leased copper. More than half of them are giving up their leased copper. Even their own copper they're reducing. So copper is more or less going away. Microwave is being reduced, and utilities are laying their own fiber. So that's what we expect to happen in the next 3 to 5 years. If you look at what are the traditional requirements of utilities, resilience, rapid recovery from failures has always been the hallmark of utilities requirements. It used to be that telecom could live with 50 millisecond protection switching, but utilities always demanded 20 milliseconds for their teleprotection needs. So it was an always-on, robust, fault-tolerant network. We expect utilities, power, railroads, oil and gas to be continually available. And a lot of the services needed to be low latency because they were affecting the performance of the grid or the railroad. Now, in Util 2.0, in the next generation, we have, of course, all of these requirements still carried over. But there is an upsurge in packet traffic because most of the traffic is going to packet, the internal traffic, because you have IP SCADA and things like that, plus video traffic due to monitoring of assets, video cameras, and that's being carried over. And since it's doable, it's affordable, you need to scale the telecom network. We need what I call operational compatibility, because you still have the legacy systems. You still have legacy SCADA systems, the sub 2 megabits interfaces, some even kilobit interfaces, TDM interfaces. Plus, you'll have high-speed IP traffic, not just from IP SCADA, but also from IP video, voice over IP, and so on. So a lot of TDM going to IP, but TDM not going away. So you need compatibility of the new technology to still carry the old traffic. You also need security. So many, there is what is IT traffic, information technology traffic, right? Which is video monitoring, voice calls, broadband data, and so on. And there's operational technology traffic, which is the SCADA traffic. Both of these are being carried on the same network, so there has to be a secure separation, because the first one could potentially go to the internet, and the next one, you don't want anyone having access to any of the operational technology traffic, because they could then mess with the network. So this security is a very important consideration. If you look at the evolution of technology, it used to be that 80% was circuit switched. In fact, we used to say utilities are sort of the bastion of SDH networking, and that's changing, and for good reasons. Packet used to be 20%, and even this packet was Ethernet over SDH. We can expect that this goes to flips 80-20, 80% packet and 20% circuit. Look at services. We had a lot of TDM services, voice, SCADA. We had some IP or Ethernet services. Now we'll have a lot more IP services, especially IP video, IP SCADA. The transport layer so far has largely been SDH or next-gen SDH. Next-gen SDH to carry Ethernet over SDH. In the next generation, we'll continue to have some SDH. It's not going to go away. But packet transport will be added in one of two forms, either an MPLS TP or carrier Ethernet. I'd still say that as one form because there are only small variations on each other. They're sort of essentially layer 2, layer 2.5, or an IP MPLS based packet transport. The medium remains the same. We have copper, fiber, and microwave, but we'll have a lot more fiber going forward, a lot less copper, and about the same amount of microwave. In terms of the technology, on fiber, fiber is used for WAN connectivity, but going forward, we'll also see fiber used for FTTX, GPON connectivity. Microwave was, land mobile radio, long links also, but in future, microwave will be LTE. The verticals on which we'll focus in this webinar will be, energy, which is power grid companies. For their inter-substation control networks, they usually have optical fiber, which is sometimes in the long distance case running inside the ground cable. There's also intra-substation connectivity for all the grid automation traffic that has to be carried. And this can be based on access technologies, what we call access in telecom, which is GPON or fixed wireless or Wi-Fi. And the traffic is SCADA, teleprotection, remote terminal units, video, voice over IP, all of those. In railroads are both intercity, like the Indian railways or metro railroads. Everything's automated, so railway stations, control centers have to be connected with optical networks. In fact, Tejas has been serving Indian Railways for their optical fiber communication for almost our entire lifetime, since 2002. And passengers also need connectivity at this station, between stations, on board the train, and so on. And that happens through a combination of GPON and Wi-Fi, and also fixed wireless connectivities. There's actually a large GPON network that was recently built by Tata Trust for the Indian Railways. You may have read about that, which connects 4,800 stations with fiber at 10 gig and distributes the bandwidth at the stations with GPON and Wi-Fi. The SCADA traffic and all that still remains in the railroad sector. Oil and gas is similar needs. You need to connect refineries and they have pipelines. So in all of these cases, there is a line running. There's a power line or a railway line or a pipeline, which is a natural place to put optical fiber. Pipelines have to be surveyed. Oil is valuable. It's being carried in these pipelines. There can be breaks, leaks, sabotage. So video surveillance of pipelines is a big requirement for oil pipelines. To a lesser degree in railroads, not so much in power grid. For oil pipelines, yes. I mean, pretty much all oil pipelines are monitored because oil is valuable. And there are offshore rigs which also need to be controlled, monitored, plus people in there need to use bandwidth. And SCADA and everything else remains. At this point, I'm going to put up a poll question. Anu will put up a poll question for about 30 seconds. So we would like to know, what is the dominant transmission technology today in your WAN network? You may be thinking of changing it. So is it SDH SONET or MPLS TP or Carrier Ethernet or IP MPLS or something else? We'd like to know, just pick one, which is the dominant one, which is the one that you predominantly use. I'll give you maybe another 15, 20 seconds because I'd like to, as many of you as possible, to get in your votes. Okay, Anu, I think 50 people voted. So maybe at 1 minute and 30 seconds, you can close the poll.
Sure, Kumar.
Oh, okay. All right, you can close the poll. Thank you. Okay, so it looks like a lot of you use IP MPLS. That's the major winner. 22 out of 54 respondents. Then MPLS TP with 11 and SDH SONET to 20. Good. So I'm sharing the results with you so you know what you can see. I should have done that a bit sooner. So moving on, we'll discuss power utilities next. Okay, on time. So the trends in power utilities are, you need smart meters to find out how we are using the electricity in our homes. When is the peak usage? How can you get us to reduce the peak usage? Maybe by charging us more or during peak hours. You need to modernize the grid. So you'll have industrial IoT sensors everywhere. You're measuring voltage, current, phase differences, frequency is going up, going down. All of this with synchrophasers technology. Do you want to reduce your operational costs? You want to make sure the grid stays reliable, it's efficient. There's also decentralized generation. You're allowing consumers to generate solar power, wind power, something else, use it themselves, as well as feed the grid. And that's also causing a lot of changes in your industry. So the emerging technologies for the communication part of this is packet transport. And most of you are familiar with the packet transport technologies. So there are, I would say broadly two. One is MPLS TP or Carrier Ethernet. I club them together because they are in many cases quite similar. MPLS TP is a transport profile of MPLS, which can be used to transport both TDM traffic and IP or Ethernet traffic. Carrier Ethernet is carrier grade Ethernet with O&M features. So the use cases for these technologies are, you can carry data, voice, video, critical traffic all at the same time. What you need to carry critical traffic is hard QoS. If you're carrying SCADA traffic, you want bandwidth, latency to be guaranteed to a millisecond or whatever is the highest possible guarantee. So you need real-time data to be carried with a very high level of QoS guarantee. So this is from your sensors and SCADA and so on. You are also at the same time partnering with governments to roll out national broadband. Every government wants broadband in all the remote areas, and you have connectivity to the remote areas. You also have microgrid in the remote area, so you need traffic carried to and from remote areas. If you look at the two packet technologies, and we had a poll, there's MPLS TP and IP MPLS. Since most of you answered this, I assume you're quite familiar. So MPLS TP is the transport version. It provides sub 50 millisecond protection. You can do multi-segment protection. It's the closest technology in the packet world, which is similar to SDH. It is provisioned using NMS, and for legacy traffic, you can also do circuit emulation. SDH was strong in O&M, and MPLS TP has pretty much the same O&M as SDH. It is MPLS at the heart of it with some transport extension, so it's interoperable. IP MPLS is always talked about in the context of IP. It is MPLS is the protocol below IP. It is not truly transport, and I'll say more about that, and it's not me saying, it's other people. There is a lot of software, it's intensive, and in terms of hard guarantees, it's not as good as MPLS TP in providing hard guarantees for latency and jitter. There is a dynamic control plane, a lot of software, and software has a higher degree of faults. The more of it you have, the more faults you tend to get. And it's not transport, so there's a lot of retraining for personnel and so on. And don't take my word for this. There are two industry organizations. One is SIGRI, which is a Europe-based, France-based. And this is a quote from their Green Book, which they published a couple of years ago. The transition to packet for power utility networks having extensive SDH infrastructure is smooth for MPLS TP because of its SDH-like behavior, while IP MPLS is a jump into another type of network operation. So I think based on the recommendations, a number of utilities in Europe and sort of Europe-allied places have started to use MPLS TP as the next generation. It can comfortably meet latency and jitter guarantees, and you can also support very rapid protection switching in the event of fiber cuts. Well, if you thought this was US versus Europe, no. The US, the North American Electric Reliability Corporation, has strictly mandated that the cybersecurity standards, SIP 02 to SIP 09, if you are using a routable protocol, there are severe penalties for non-compliance. So effectively, they're discouraging the use of a routable protocol, and IP is a routing protocol. It is definitely a routable protocol. So MPLS TP being a true non-routable layer 2 service, you have less risks and an easier time complying with the security standards from NERC. Another advantage of MPLS TP is timing. You now need accurate time across your network. So MPLS TP supports 1588 based packet synchronization, and this can give you 1 microsecond of timing accuracy, which is really what you need to run your current power network switch with. I won't get into how 1588 works, but 1588 V2 does deliver 1 microsecond of timing accuracy. Actually, it can deliver better in telecom networks because of the localization needs, but it's more than enough to meet the requirements of the power sector. Other requirements in the power sector is you need to backhaul metering data, because if you have automated metering, that needs to be backhauled. Typically a wireless link to the meter. It can be based on newer technologies in LTE like narrowband IoT, and then backhauled over the distribution network. You need WAN connectivity. Again, used to be STM16. Now it can be 10 gig with ERPS at G.8032. And next-gen SDH still works for low-capacity WANs, but you need MPLS TP for high-capacity WANs. If you have remote energy microgrids, then they can also be connected by GPON. GPON is a fairly reliable technology because it's passive. The infrastructure is passive. So therefore, you are the power grid, but you may not be supplying power everywhere along the way. So for remote broadband connectivity, GPON is a good option. You can also use GPON to serve homes, and you can use carrier Ethernet to serve businesses, fixed wireless as well. So when you serve remote areas or microgrid services, you can also provide broadband to homes and businesses there. Poll question 2, I'm running a little behind time, but Anoop, if you can prop up the poll question. we asked, what is your dominant transmission technology today? What do you think is a transmission technology that will be dominant in your network in 2025? That's the next question. Okay, we're up to 51, 53, the same number of respondents as the first question. So we'll close the poll at 60 seconds, Anu. And Sharath, I'll try to finish in the next 6 minutes, leaving you with about 15, 20 minutes. Okay, we close the poll, if Anu closes the poll, I'll share the results. So we had 34 of the 60 respondents saying MPLS-TP is likely to be the dominant technology. Of course, a lot of you are still sticking with IP-MPLS, which is fine. So let me go on to the next segment, which is railroads. In railroads, mobile subscribers need, of course, you no longer pay with cash or credit card for anything. You need fare automation through some app. You need apps to tell you when the train's coming, going, what's the capacity of the train. The metro guys need to figure out how many passengers are waiting. You need Wi-Fi everywhere. How are you going to do social media? All stations need to be monitored, managed. Maybe COVID will add its own gamut of monitoring requirements for mask and sanitizer and everything else. We don't know. So everything's changing, but we will cope up. You also need to automate the infrastructure. Safety of the infrastructure is a big issue. Everybody wants zero accidents. And I think we had the first zero accident year last year in 2019, if I'm not mistaken. I think Indian Railways announced zero accidents. You can check that. And you need to optimize capacity, like metro guys want to run the fewest number of coaches based on the number of passengers. And railroads are often not making enough money. They want to do value-added services. I think broadband is one of them. Broadband on the train, broadband on the station, broadband to the community. And so you can add value, you can add revenue also perhaps. Okay. Technologies, of course, some of the MPLS, TP and all that still applies. But I want to talk about one particular technology which has been effectively used to build a network across thousands of railway stations, which is GPON combined with ERPS. So GPON is asymmetric broadband. XGS-PON is symmetric at 10 gig, but GPON is the most widely used technology. Pretty much every one of you would have a GPON connection at home. But we combine that with another technology called OpenERPS, so it is 50 millisecond protection on open packet rings. I'll describe that in a minute. The use case here is public Wi-Fi in railway stations, track surveillance. You can backhaul mobile data, mobile telephony, mobile data from mobile towers, cell towers in remote areas. You have internet access to business and homes. You can distribute digital video. So here's the network that we built. This was built for the Indian Railways by Tata Trust, and we were happy to be a partner to Tata Trust. And I can quote here from Sri Ram of Tata Trust, who said, within 3 months, we had installed the equipment at more than 3,500 stations and commissioned 3,000 stations. This is out of 4,800. This is published in their magazine, Tata Trust Horizons. I believe this is one of the world's largest public Wi-Fi networks. It has 15 million users. We're using 10 petabytes a month. So this is how the network technology works. Is a 10 gig, I won't say ring, a 10 gig network on the railway lines connecting all the stations. And you have, periodically every, 100 stations, tens of stations, every few dozen stations, you have an uplink to the internet. And then at each station, you have, drops into Wi-Fi access points. This can be extended to the surrounding town as well. The protection we did here is somewhat novel. So let's say these OLTs, different stations, could connect to Internet Gateway 1 in the south, south meaning bottom of the diagram. And if there's a fiber cut, the traffic goes to the northern gateway. and it does so in 50 milliseconds. So this is a good way to build protection in networks, right? Railroad networks, where a ring is not the natural topology. This network, which now provides Wi-Fi at the stations, can be extended for monitoring the track on either side. The GPON usually supports 64, 128 ONTs in each direction. So you could put 30 ONTs in each direction every 100 to 200 meters, and you can monitor the track. You can provide Wi-Fi connectivity to passing trains, because the GPON can just backhaul the Wi-Fi from the trains. So there is all these applications that you can use the same network for. And if you are at this small town, you can provide internet access to businesses and homes, extend the GPON network to homes, extend maybe a carrier Ethernet network to businesses. So you can transform or digitalize, I think is the right word, the town or village. So create a digital India. You can also distribute video in the towns, in the community, using this. So the same GPON actually is a natural technology to also distribute video. So that's also quite possible. So the imagination is your limit. You can imagine more services now that we have this network. So the next poll question for you is, if you're a rail utility, or you can pretend to be one, we don't mind, are you planning to leverage your right of way to launch Wi-Fi or other fiber broadband services? So we'll give you 60 seconds to respond. And after the end of the poll question, I request Sharath to take over. So I have 25 responses, but there are 92. So I'm at least looking to cross the halfway mark. Sanu, give us a few more seconds. Okay, we are at 40 responses, almost to the minute. So Anu, you can close at 1 minute and 15 seconds, and Sharath, you can take over.
Okay. I'm closing it.
Okay, thank you. So over to you, Sharath. As I share the results, yes, so you're using the railroad project. It's ongoing for most people, and I would say, majority are it's either ongoing or you're going to use it in the next 1 or 2 years.
Yeah, thank you, Kumar. That's about 67% of the people who
okay, it's good.
expect to move to that. Yeah. So in the next few slides, I would first give some of the recent trends and the technology evolution in the oil and gas sector, and what are the solutions that are available. So there is a lot of commonality with what Kumar has already mentioned. Basically, there are 3 drivers for this. First one is the automation and infrastructure digitization that's happening because of the availability of very low-cost IoT sensors, and also the technologies available to interconnect these in a very cost-effective manner. And the second aspect is, of course, the enhanced physical security. So this is a critical infrastructure. So the physical security is also very important especially along the pipelines. And here there is a lot of use of video surveillance technology. And that also brings in a lot of computing and requirements for edge connectivity to analyze the security data with automated video analytics to figure out intrusion detection and so on. So these are the 3 key industry trends, just as other utilities that are there in the oil and gas sector as well. Now, so what are the emerging technologies that are enabling this? The first one is the LTE. 3GPP release 15 especially brings in massive machine type communications. So basically that enables a connectivity for a large number of these IIoT sensors, and also with the significantly enhanced data rates because of the the MIMO technology that is part of it. So these are the two key aspects, other than the much wider bandwidths that it enables. And of course, another important aspect of the LTE is the evolution, developments in the front-haul standards. So this basically facilitates the development of these inexpensive base stations or node Bs with a lot of the processing that is centralized, so that you can actually scale much better. I mean, because of the shared use of the processing at the central stations, the overall the cost effectiveness of a solution becomes more prevalent, and also scales so that you can add a lot of base stations without significant investments. And so there are three kinds of requirements in this one. One is the connectivity in the campus networks, right, to aggregate the sensor and control traffic. And second one is how do you provide the physical security and also the maintenance solution with and what kind of wireless networks that you can build, the high-speed wireless network, especially the remote oil fields and offshore rigs. There is no way that you can actually take wired infrastructure to there, and so you actually need a very high-capacity wireless link. The first part of it is the WAN connectivity, and Kumar already described the prevalent technologies which are there, which is SDH, and there's a lot of migration to packet technologies based on MPLS TP as well as IP MPLS, and she already discussed the role of the role of these technologies. So this WAN connectivity facilitates interconnection of these the refineries and pumping stations. So this is the backhaul network. Again, there are two kinds of networks that are involved here. One that is for a captive network. The second is if the oil and gas company concerned is also interested in offering the bandwidth, providing bandwidth over this network for a third-party networks. So there are two applications over the WAN. So what is shown here is aggregation network which is captive, and on top of it there can be a high-capacity OT and DWDM network to provide services to other operators. And of course, there are two other aspects. How you provide the connectivity within each of these pumping stations. So there, the GPON or fiber to the home, wherever there is there's fiber that is available. Say for example, if you want to connect all the sensors along the pipeline, which actually monitor all the gas leaks or whatever is the control or carry the control traffic as well as video surveillance traffic. So this is can be carried over a GPON network. Because of the video surveillance, you need fairly high capacities, and that can be provided very cost effectively using a GPON network. Here I'm just showing you using an ONT which actually connects these cameras. And a similar DPON technology, again, as Kumar emphasized, can also be used to provide connectivity to the nearby homes or enterprises, because this is going along the rural segment, which may not have very high capacity connectivity. So now that the network is there, so this can be used to either monetize or offer these services. The last bit is connecting the remote oil fields and oil rigs to wireless links, because as I said, the fiber may not be an option here. So this is where you can use LTE fixed wireless as the technology based on the requirements. So this is used for transporting telemetry data as well as providing internet access and connectivity to the personnel who are located at these remote locations. So left side you see the wireless, the reach is typically 5 to 10 kilometers, and that goes to a 4G tower and a backbone node, which actually terminates the LTE and then puts it over a WAN network. And in terms of the backhaul technologies, what is the dominant technology if you want to, as an evolution, that comes as an evolution of SDH. So that is the OTN layer. Basically uses the same kind of methodology as SDH to multiplex higher and higher capacities. Is where SDH stops, that's where OTN starts. So it starts from 10 gig lambdas. And then OTN 2.0 is 100 gig, but now you're actually talking about much higher capacities with 400 gig lambdas. So this, the OTN 3.0 brings in a lot of flexibility in terms of the capacities and also the client signals that can be carried over. So they can be 25 gig, which is very popular in, say, for example, in front-haul kind of applications, or it can be 40 or 100 and so on. So there's a flexible client mapping mechanisms that are brought in. And this is an ultra low latency and deterministic transport. All the capabilities that we are familiar with in SDH network are carried over fairly seamlessly into the OTN network with a very similar OAM capabilities. And this also provides a very secure network partitioning. Security is an important aspect. So that is naturally provided in this network with IT OT convergence. So this shows basically how we can build an end-to-end network. So there is either SDH, NG-SDH, or a PTN in the access layer, aggregation layer, and a core layer consisting of OTN. And then of course, going towards, you can actually build very high capacity cross connects based DWDM system. Okay, now we go to poll question 4. So which of the following broadband access technologies are used in your network? So you can select multiple options based on which ones you are using today. So Ethernet seems to be the most dominant technology, followed by Wi-Fi, and GPON also seems to play a fairly significant role. Okay, we can probably close here. Okay, now I'll be talking about a little bit about the solutions that we offer as Tejas Networks. So we are the largest supplier of communications equipment to the power sector, and have more than 8,000 plus nodes that are deployed with our NG-SDH. So we've been there in this since 2002 time frame, and we also deployed pan-India wholesale network based on NG-SDH, PTN, and DWDM. We also have a fairly large share in the Indian Railways network with over 7,500 plus nodes, and that's in railways, and 10,000 plus nodes. And Kumar has described some of the applications for which we deployed this network. The public Wi-Fi project that's also described, and technologies deployed are pretty much all that I've described: NG-SDH, PTN, DWDM, as well as GPON. Similarly, in oil and gas sector, we do have equipment for transmission, surveillance, and connecting all these, the SCADA networks and so on. So again, NG-SDH and PTN are the technologies that are deployed. So I'll quickly run through what are the offerings that we have for this utility network. So in the access space, we do have a broadband access product. So it's one product which can support the needs of pretty much all the access technologies that we have seen, whether the need is for a GPON network or a Wi-Fi or a LTE, whichever of the three technologies, you can actually, through the appropriate plug-in cards, it's the same platform that can be used. And it can also be used to transition from, say, for example, initially the connectivity is through wireless and later on wired. So that's what we do in the access space. In the edge space, we have fairly versatile products based on next generation SDH, MPLS-TP, and also OTN. All the three technologies that we have described, fairly large portfolio of products that are fairly widely deployed. In the core space, we do have multi-terabit OTN switching products that start from 640 gig of SDH slash OTN and going to multi-tera DXs. And we do have a very strong coherent DWDM portfolio with coherent optics and up to 600 gig capacities per wavelength. It's a fairly full-featured portfolio with multi-degree ROADMs, MDUs, amplifiers, including Raman amplifiers, and so on. And some customized applications, specific applications where there is a fiber scarcity, we can actually build single fiber solutions, DWDM on a single fiber with ultra and also ultra reach communications. So this is a slide on the universal access platform. This is the platform I mentioned. It supports with a plug-in module. We have a plug-in module that provides LTE functionality, which is upgradable to 5G. And we also have a GPON module that goes to the same platform. So what we call the ultra converged access edge portfolio. So this also has the WAN technologies that are integrated so that just one box can meet the requirements of access as well as aggregation, providing the needs of wired as well as wireless communication. So this is a pretty unique product that won a lot of awards. So this was the finalist in Leading Lights Awards, and also the Broadband World Forum. It also got a Fierce Innovation Awards. And what do we do for advanced packet transport implementation in these products? We do have very strong synchronization mechanisms which are required in these current generation communication networks, including SYNCI and 1588 functionality. Very dense circuit emulation. So if you have networks from legacy which need to be upgraded, so we can do high capacity circuit emulation, can go up to 160 gig of TDM circuit emulation, just one of these boxes. And that can circuit emulate E1, C3, the STM14 and 16 and 64. OAM tools, whatever you're familiar with in SDH world, a similar kind of functionality or capabilities exist in MPLS-TP portfolio. And the protection mechanisms. So this is another important thing, being able to provide 50 millisecond protection switching either with, we have multiple technologies here. MPLS-TP is one. There's also Ethernet ring protection. So this is a summary of the slide, which actually talks about the complete end-to-end network. So we do have end-to-end portfolio with starting from SDH and packet on the access with the PTN or OTN in the aggregation layer and a high capacity DWDM. So I would like to hand over now to Kumar to summarize.
Thank you, Sharath. Let me share my screen. So first, before I begin, I would like to ask people, the audience, to ask questions in the Q&A window. I see very few questions as of now, so please do ask while I am summarizing. Am I audible, Anu or Sharath?
Yes, Kumar.
Yes, okay, good. So summary is that in all the three utility networks, which may be energy, railways, oil and gas, there's a surge in packet traffic, and this is really driven by the modernization initiatives, video surveillance, as well as providing broadband. Now the technology, so smart grid, automation, video surveillance, and all of you are transitioning your network from SDH to service this packet traffic. But your challenge is you can't sacrifice the mission critical performance, SCADA traffic, teleprotection in the oil and in the power sector. Everything has to continue unabated. There are new forms of teleprotection, distance teleprotection, differential teleprotection. Your synchronization requirements are getting more stringent with all the synchro phaser technology, remote microgrids, AMI, AMR, distributed generation, everything. And so you can't sacrifice mission critical performance, but you need to move to packet technology. And I know a lot of you are, maybe using IP MPLS, but please do consider MPLS TP. It's a non-routing technology. It is recommended by the SIGRI, which is the Power Industry Forum. It is recommended by the indirectly recommended by the North American Energy Research Council, being a non-routing technology. And it's not only Tejas, but I also talked to other industry folks, OEMs, and they're also betting on MPLS TP as being the next technology for packet transport. So please do consider that. It's very good from meeting all your transport requirements. It's also very good from a security perspective. It works and feels like SDH, but it's packet. It carries packet traffic. Lastly, I want to thank all of you, because while you're modernizing your network, you're also enabling your own countries to get more digital. So every country is undergoing a digital transformation, which is as important as the Industrial Revolution about 150 years ago. No one wants to be left behind. The developing countries today were the ones who got left behind in the Industrial Revolution. So no country wants to be left behind in the digital transformation. And it is actually the utilities, power, railways, oil and gas, which are enabling their countries to become more digital, to become entirely digital, especially where it's critical. Critical is in the remote areas where they have no broadband connectivity to their homes, or they have some kind of wireless, GPRS or 3G connectivity. Even LTE does not reach. So reaching homes with wired broadband connectivity or LTE broadband connectivity, businesses in remote areas, is a critical need for digital transformation of nations. And I think all of you are playing an extensive role in that with your infrastructure, which extends to all parts of your country. And we are working with many utilities. We're happy to do that and to transform the world. So I will stop here.